Infrared thermometer is the easiest and the most common device used to measure body temperature. The device gives a quick reading and operates in non-contact mode. This feature makes it different from the mercury or digital thermometer. Being contactless, there is no risk of spreading infection while using this device. Let us learn how an IR thermometer works. All hot objects, including human body, emit thermal radiations, predominantly infrared or IR radiations. By measuring the intensity of the infrared radiations emitted by our body, an IR thermometer gives our body temperature reading. There are 4 basic components in an IR thermometer. 1. Lens, 2. Sensor, 3. Processor, and 4. Display unit. The IR rays from our body is first focused onto a sensor using the lens. Most IR thermometers use a device called the thermopile as a sensor element. Let us see what a thermopile is. When one end of a conductor is heated, the electrons there vibrate more. These electrons repel the adjacent electrons, and the repelled electrons move towards the colder end of the conductor. This causes an accumulation of negative charge in the cold end. In turn, the hot end becomes positively charged. Thus, a potential difference is created between the hot and cold ends of the conductor. In simple words, when there is a temperature gradient in a conductor, a potential difference is created across its ends. This effect is called Seebeck effect. Thermocouple is a temperature measurement device which works using the principle of Seebeck effect. This Seebeck voltage varies with the conductor used. The potential difference or the voltage varies according to the temperature difference between the hot and cold ends. We can consider this as a battery. If we connect the hot and cold ends of conductor 1 using a different conductor, say conductor 2, there is a current flow through the conductors 1 and 2. One thing to note here is that over time, hot and cold junctions are formed in the conductor 2 as well, generating a Seebeck voltage. This voltage created in the conductor 2 causes a flow of current opposite to the direction of current in conductor 1. This reduces the net current flow. To maximize the net current flow, we need to choose one material with high Seebeck voltage and a different material with low Seebeck voltage. This pair of conductors is called a thermocouple. The amount of current in the thermocouple depends on the temperature difference between the hot and cold junctions. So, if we measure the amount of current, we obtain the temperature difference. The temperature difference is added to the cold junction temperature to get the hot junction temperature. As the current produced by a single thermocouple is low, we use a thermopile, which is an array of thermocouples. The thermocouples are arranged in a thermopile such that all hot junctions are positioned together and all cold junctions are positioned together, separated by a thermal resistance layer. In an IR thermometer, the infrared rays are focused by the lens onto a junction on the thermopile, making it hot. The temperature of the hot junction changes according to the intensity of the infrared rays. The resulting current is measured, and this gives the temperature difference between the hot and cold junctions. The temperature of the cold junction, which is usually at room temperature, is measured using a contact sensor. From this, we get the hot junction temperature. The relation between the hot junction temperature and our body temperature is obtained experimentally. Using this relation, the processor circuit converts the hot junction temperature to the corresponding temperature of the body. The temperature reading thus obtained is what we see in the display screen on the infrared thermometer. This is how an IR thermometer gives our body temperature without any physical contact. The laser pointer in the IR thermometer is used to aim the device accurately to the surface whose temperature is to be measured. I hope you understood the working of an IR thermometer that we commonly use. Please hit the like button and share this video if you find it interesting. Do subscribe to our channel But Why? I will see you with another informative video next week.